The diagram shows the curve y equals 4 plus 3x minus x squared intersecting the positive x-axis at the point A. The line y equals mx plus 8 is a tangent to the curve at the point B. We want to find the coordinates of A, so that's just where this is going to cross the axis. So if we've got 4 plus 3x minus x squared, we don't need the bracket there, is equal to 0, or I prefer to have my x squareds positive when I'm doing this, so x squared minus 3x minus 4 equals 0, and so we've got x and x, 4 and 1, minus and plus would do that, so x is equal to 4, or x equals negative 1. Now clearly this one's the negative 1, so this one's the 4, so A is the point for 0. The value of m is the next thing, and that is the gradient of this tangent. So we know that these intersect at the point B shown, but there's only one solution to that. So if I try to solve them simultaneously, so I can have mx plus 8 is equal to 4 plus 3x minus x squared. Bring everything over this side, and we've got x squared plus m minus 3x, so that's the mx take away 3x, plus 4 is equal to 0. We know that b squared minus 4ac for this quadratic is equal to 0 because it's a tangent. There's only one solution. So we've got m minus 3 squared, take away 4 times 1 times 4 equals 0. So that's m squared minus 6m plus 9, take away 16 is equal to 0. So that's m squared minus 6m minus 7 equals 0. And so m and m, 7 and 1, minus and plus. So m equals 7, or m equals negative 1. And it's clearly not that one, because we can see that we have a negative gradient just from the picture above. You can see it slopes down. So m is equal to negative 1, and therefore it's negative x plus 8 is that. So the coordinates of B is the next thing to find. And having found that m's negative 1, this quadratic equation becomes x squared minus 4x plus 4 equals 0. We can see that quite clearly because the m's negative 1 there. And that is just x minus 2 squared equals 0. So we've got x is equal to 2. And we know that y is equal to negative x plus 8. So y would be equal to 6 if x is 2. So B is the point 2, 6. And finally, I think it's finally anyway. Yep, finally, we want to find the area of the shaded region. So let's go up and look at what we're going to use as a strategy there. Well, what we could do is work out the area of the triangle, like so. Now, because we know it's y equals negative x plus 8, we can figure out that that intercept there is at 8. We know this is at 2, x equals 2, we worked that out just now. We know this one's at 4. So I could work out the triangle and then take away this area, which would be the integral of the curve between 2 and 4. So the area is going to be equal to the area of the triangle, which is a half times the base, and the base went across from 2 to 8, which is 6, times the height, which we know is the 6. That's the height of B here. So that's the triangle. Take away the integral from 2 to 4 of the curve, which is 4 minus 3x, no, 4 plus 3x minus x squared. I'm just going to go back and check that. 4 plus 3x, yeah, minus x squared. That's the one. So 36, half of that is 18. Take away. So what have we got? 4x plus 3x squared over 2 minus x cubed over 3 from 2 to 4. So it's 18 take away. So using the top limit, we're going to get 16 add 3 times 16 is 48. 48 divided by 2 is 24. Take away 64 on 3. Take away, if 2's in there, that's going to be 8. 3 times 4 is 12, divided by 2 is 6, plus 6. Take away 8 over 3. So, where's all that disappeared to? Okay. It's a slight glitch on the computer there, but no big deal. So we can work this lot out.